everything. Usually antenna has a specific shape. So what specific shape? You have a source, you have a microwave transmission line. This is your antenna part which radiates your EM waves. So this is what you have studied. Now suppose you look from a very far off distance, some space, or from around a very large distance, your antenna will look like your point source, like this one small point. You can't know the shape of the antenna. So like this you have various point sources. I will come to the history of point sources. So if you are looking at that antenna from a very large distance, it does not have a specific shape. Now this idea of point source goes back to way back to your World War II. Let me write the definition and explain to you. Then I will tell you some sort of story on that. An antenna which does not have any specific shape okay, is called a point source. Okay. It is also said to be a isotropic. I'll tell you everything, so don't panic if you get some new words. Isotropic radiator. It is also called as isotropic radiator. Okay. Next. Okay. Isotropic radiator is a point source. That radiates with equal intensity in all the direction. See, I'm writing very slowly instead of reading out. Already I have this notes because it has to enter your mind and you have to reproduce this in the examination. Just I am just reading will not solve your problem, because I am just not presenting here. I am trying to teach you for the examination point of view, 360 degrees. So it is nothing but a point source which radiates equal intensity in all direction, and your point source does not have any specific shape. So I'll just put a round in color is your point source. Okay, wait. Yeah, fine. Observations. This is known as your observation circle. Observation circle. This is your point source antenna. This is your point source. It is very small. So this is your antenna here, so which is acting as a point source. When you are seeing from a very large distance, so this is very small as compared to this one, and it does not have any specific shape and size. And any point source will radiate with equal intensity in all direction, 360 degree. That is known as your isotropic. Radiator. This is very important concept. Isotropic radiator is a point source which radiates with equal intensity in all the directions without any bias there. So in general, okay, So this is your observation circle antenna. So your isotropic radiator, so that is your point source definition. So your isotropic radiator will be something like this. So it will radiate with equal intensity in all the directions. Isotropic radiator will radiate with equal intensity in all the directions. That is the concept of your isotropic radiator. So I'm trying to put arrow marks to depict that the isotropic radiator will radiate power with equal intensity in all the directions. So almost these arrow marks should be of similar length. So So this is your isotropic radiator. So in between you will have this is your point source here. Okay, so this is your point source acting as a isotropic radiator. Point source acting as an isotropic radiator. So what is the use of this point source and arrays is actually this I'll just tell you one small story before going forward. So this came into existence in World War II for the concept of radar. Suppose this is some land, okay, you have one antenna here, one antenna here, one antenna here, one antenna here. Assume these are at space of 10 kilometers. So each antenna is spaced at 10 kilometers. So when you see from a very far off distance, this act as a point source. So this act as your point source without any specific shape. Suppose this is one shape, this is one shape, this is one shape, this is one shape. But when you are looking from a far off point, this is all point sources. So suppose these acts as your radar. So if you have any incoming aircraft coming or incoming missile or whatever it is tracked here. So from this the information goes to a central control unit or whatever you call. There you have the processing unit. So if the aircraft enters here, from this I can measure the distance. The electromagnetic waves will come and impinge back. From here also I will get the approximate distance. So with these two data I can find out the exact location of your aircraft. Similarly, if there is another aircraft which is coming here, similarly I will know the distance from here to here, here to here. So the entire area is what to say, covered by these kind of antennas which are acting as point source, which are placed at very close to each other. Okay, recently you have this Israel-Palestine conflict. There this kind of concept was used. That is, if you have they have what is known as an iron dome system. Iron dome system. Okay, this is what the Israel have. So any incoming missile or aircraft, these kind of point sources will detect these kind of incoming missiles. I'm only telling the technical part of it. Then these will go to a centralized control unit. From the control unit, you have anti-missile systems here, which will exactly track the location. This is more sophisticated than what I'm trying to explain to you. It will exactly track the location, and from here a counter missile is launched to hit the missile in the air. Okay, so you would have seen lot of news, and in the internet you can even search your iron dome system of Israel. and this is very effective in tracking the incoming missiles and destroying it. So in general, point sources are used for your radar applications to cover the entire area. It can be used for civilian purpose, military purpose, or whatever it is. That is the use of your point source. So as an array of point sources are usually used, a single point source will not be used. So this is a collection of some 5 to 6 point source. From that, signal will be going to a central control unit. There I am going to process it, and this one. So I am telling in a very simple manner for you to understand. So there are more complex concepts involved, and some of them we'll be studying in this module. So point sources cannot exist in singly. In practice, you have what is known as array of point sources. Okay, in practice, we have what is known as array of point sources. Okay, write down an array system is combination of more than one antenna, that is point sources, arrays can be constructed either from similar or dissimilar antennas. Arrays can be constructed from similar or dissimilar antennas. The resultant pattern of arrays depends on the following parameters. Depends on the following parameters. Okay. First one is known as number of antennas. So your resultant pattern of the array means what will be the radiation pattern of the array. If you have more than one point source in array or more than one antenna in array, what is the resultant pattern of the array? See, I am all of you are the students of this class. So one student may get some higher marks, one student may get an average marks, and one student will get slightly lesser marks. So your resultant effect of the class will take average of that. Similarly, if you have many antennas, each antenna will not act independently in your point source. Although they may act independently, the effective result of all the antennas in the point source needs to be considered, and the resultant pattern of the radiation pattern should, in order to be considered, these are the following parameters to find out the resultant radiation pattern of the antenna. I hope you are getting what I am trying to tell. So in that case, you have number of antennas. So these are the various parameters which are affecting the resultant. So you have number of antennas. Second one, you have shape of the individual antennas in the array. Shape of the individual antenna in the array. Okay, fine. Individual pattern of each source, individual radiation pattern of each source, distance between the two antennas in the array, two antennas in the array, power magnitude of each antenna, power magnitude of each antenna, phase difference, seventh one you have array dimension. Okay, array dimension. Okay, next topic what we'll be reading is various. I hope you have noted down these points. Individual radiation pattern of each source, shape of the individual antenna in the array, distance between the two antennas in the array, power magnitude of each antenna, phase difference, and array dimension. Okay, then various forms of antenna array. Various forms of antenna array. First one, broadside array. Second one is end fire array. End fire array. Third one is parasitic array. Parasitic array. Fourth one is collinear array. Collinear array. Collinear array. So these are the different types of array. So the first one, what we'll be studying is your broadside array. These are various forms of antennas arrays which are made up of various point source which are isotropic point source. Isotropic point source means they radiate with equal intensity in all the directions. So anyway these arrays are formed by point sources. Please write down. It is one of the most important array. Broadside array. It is one of the most important and commonly found antenna array. In this type of array, the elements in the array, the elements in the array are placed parallel to each other, and the direction and the direction of the maximum radiation of the array is in a plane perpendicular to the elements in the array. This is your broadside array. There is one small diagram. Please draw the diagram in that. I will tell you what is the significance of this broadside array. So instead of point source, I'm drawing rectangular blocks to understand better. So these are basically point sources only. So I'm looking at a very close distance. Therefore, they are looking with some shape. Otherwise, these are point sources. So don't get confused that I'm drawing something else. These are basically your point sources, which are spaced at equal distance with respect to each other, which are almost placed with respect to equal distance. This is your distance D. This is your distance D. Okay, this is your antenna 1, this is your antenna 2, and this is your antenna 3. Okay, so your direction of maximum radiation so this is your direction of maximum radiation. Please remember, in case of broadside array, your direction of maximum radiation is always perpendicular to the plane containing the array. So this is the most common form of array of point sources which are used in practice. Which one? Broadside array. So we will be telling mathematically how this broadside array is all established. So your direction of maximum radiation in case of broadside array is always perpendicular to the plane containing the elements in the array. Next thing what you have is end fire array. That is the second type of array we are studying. End fire array. Yeah. So in your end fire array, almost it is very similar to broadside array. Your direction of maximum radiation will be along the axis. So how to realize that? We'll be doing these things mathematically. So this is your end fire array I'm trying to draw. So these are the various elements of the antenna. Suppose I call this as antenna 1, 2, and antenna 3. You're reversing the direction of the phase of the current, you will realize your end fire array. So that all that we'll be doing mathematically. So this is your distance D. These are the elements of your antenna. Antenna 1, antenna 2, antenna 3 of the part of the array. So your direction of maximum radiation will be along the axis containing the array. Direction of maximum radiation will be along the axis of the array. Okay, so this will be your direction of maximum radiation. Direction of maximum radiation. Okay, in case of, just write down, in case of end fire array, the direction of maximum radiation is along the axis, containing the elements of the array. Okay, this is the your direction of maximum radiation. Then other two types of array is parasitic array and the collinear array. Okay, so these two types of arrays are the maximum used, and usually they won't ask what is your parasitic array and collinear array. So this is what will be asked. So what is broadside array? Your direction of maximum radiation is to the perpendicular to the axis containing the elements of the array, whereas in the end-fire array, direction of maximum radiation is along the axis of the array. Next, a very important concept what we are going to start here is now array of 2-point sources. Now this is mathematically very important from your examination point of view also. Array of 2-point sources. Okay. Array of 2-point sources is nothing but an array of 2 isotropic radiators. Isotropic radiators means this is nothing but a point source, and this point source will radiate with equal intensity in all the direction. Isotropic radiator is nothing but a point source which will radiate with equal intensity radiation in all the direction. That is your definition of an isotropic radiator. Okay. It radiates with equal intensity in all the direction. Under this array of 2-point sources, first write down case 1, array of 2-point sources supplied with currents of equal magnitude and phase. Array of 2-point sources supplied with currents of equal magnitude and phase. Array of 2-point sources. So this will be very important from your examination point of view. They will be telling derive an expression of array electric field due to array of 2-point sources supplied with currents of equal magnitude and phase. Okay, I just forgot to write here electric field